Good morning, my dear Prep 1 students. Hope you are all fine today. I would like to welcome you all to the new academic year. My name is Miss Sarah Al-Hilali and I will be your mathematics teacher for this year. Today, we are going to begin our first revision video. We will start revising different sets that we have studied previously in primary 5 and 6. So, let's go and start and see what is the first set that we are going to revise. The first set is the set of counting numbers. Do you remember what was counting numbers? If I asked you now to count how many chairs are there beside you, you are going to start counting by 1, 2, 3, 4, and so on. So, counting numbers are the set of positive whole numbers. Counting numbers is set of 1, 2, 3, 4, and so on. This means that the set of counting numbers is infinite. What is the meaning of infinite? It has no end. I know that it begins from the number 1, but when does it end? It has no end. It's an infinite set. The second set that we already studied in primary 5 was the set of natural numbers. What are natural numbers? Natural numbers are the set of 0 and positive numbers. Oh, let's stop here. Didn't we say that counting numbers is set of positive numbers? So we can say that natural numbers are set of positive numbers union set 0. Natural numbers equals set 0, 1, 2, 3, 4, and so on. Again, natural numbers are infinite set, meaning that this set has no end. I know it begins with 0, but I don't know exactly where does it end. But keep in mind that natural numbers must be whole numbers, no fractions or no decimals. Let's have a look here at this number line. Here is the number line representing natural numbers. As you can see here, all those red numbers, they are positive numbers and 0. So, this is the number line representing natural numbers. Let's go now and see what is the third type of set that we have studied in primary 6. We have studied integers. What are integers? Integers are the set of whole numbers and their opposites. Integers are positive numbers, 0, and negative numbers. The number line for integers goes on forever in both directions, and this is indicated by arrows. And please remember that the integer 0 is neither positive nor negative. 0 is a neutral number. I can't say that it's positive and I cannot say that it's negative as well. So we can say that z is equals to z positive union z 0 union z negative, which means that all the positive integers, all the positive whole numbers and 0 and all the negative whole numbers as well. Those three together make up z, or make up the integers. Let's have a look here for this number line. We said that 0 is neither positive nor negative. On the right hand side you will find the positive integers, which are the positive whole numbers. On the left hand side, here are the negative integers, which are the negative whole numbers. So, the three of them together make the set which is called the integers. What about when we said that integers are the set of whole numbers and their opposites? Let's go again and have a look on the number line. What is the opposite of 1? The opposite of 1 is negative 1. Why? Because it is the same distance away from 0. And this is negative 1 is the opposite of 1. Negative 2 is the opposite of 2. 3 is the opposite of negative 3. Negative 4 is the opposite of 4. Let's go now and see what are the absolute value. If you remember that an absolute value of a number is the distance from 0, meaning that this number is how many units away from 0. Can a distance be negative? Of course not. Distance cannot be negative, so the absolute value cannot be negative as well. Let's have an example here and see. The absolute value of 5, this means I want to know how many units is 5 away from 0. 5 is away from 0 by 5 units, so the absolute value of 5 is 5. What about the absolute value of negative 5? When I say absolute value, I mean how many units is this number away from 0. Negative 5 is 5 units away from 0, so the absolute value of negative 5 is 5. And it's so logical that the absolute value of 0 is equal to 0. Why? Because 0 is the origin. But remember, there is something very important. The only way when I will get a negative answer for the absolute value is when I have the negative sign outside of the bracket of the absolute value. So if I said that negative absolute value of 5 and the negative is outside the bracket, as a result of this, I will have the answer of negative 5. Why? Because I am finding the absolute value of 5 and adding to it the negative which is outside of the absolute value sign. Now, let's go and have a look at this number line. This number line is the number line for integers, right? We said that the absolute value of a number is how many units it's away from 0. So, if I said here 5, 5 is 5 units away from 0, right? 1, 2, 3, 4, and 5. And how many units is negative 5 away from 0? 1, 2, 3, 4, and 5. So that's why the absolute value of negative 5 is 5. The same is going to happen if I asked you what is the absolute value of negative 3. This means how many units is negative 3 away from the origin, which is 0. You will find the absolute value of negative 3 equal 3. Now, let's remember what does belong and doesn't belong mean, and what are the symbols we use for belong and doesn't belong. This symbol means the belong of an element to the set. This means that this element is found inside of this set, while this symbol means the element doesn't belong to the set. This element is not inside of the set. And remember, belong and doesn't belong are used between elements and sets. I must have an element and a set. Then I will decide this element belong to this set or doesn't belong to this set. Let's have an example. If I'm telling you 8 and set 2, 4, 9, and 8. This is an element and this is a set. Does this element belong to this set? Yes, it belongs to this set. It's found inside of this set. So 8 belongs to set 2, 4, 9, and 8. What about negative 10? Negative 10 and z. Does negative 10 found inside of z? Yes, sure. We said that z contains all negative whole numbers, 0, and all positive whole numbers. So negative 10 is found inside of z. Negative 10 is an element and z is a set. So negative 10 belongs to z. The last one is we have negative 6 and n. Negative 6 is an element and n is a set. Negative 6 is a negative number, and we said that n contains 0 and all positive whole numbers. So, does negative 6 found inside of n? Of course not. So here I will say that negative 6 doesn't belong to n. What about subset and not subset? Here are the two symbols for subset and not subset. what does each one of them mean? Let's go and see. This symbol means subset. All the elements of the set is found inside of the other set. And this symbol means not subset, meaning that not all the elements of the set is found inside the other set. So, if only one element in the set is not found inside the other, so it is not subset. And remember, subset and not subset are used only between sets. Let's have an example now and see. Here I have set 8 and set 2, 4, 9 and 8. My question is, does set 8 with all its elements found inside of the other set? Yes, set 8 with all the elements is found inside of the other set. So, set 8 is subset of set 2, 4, 9 and 8. Let's go to the other one. I have here 8 and set 2, 4, 9 and 8. Can anyone tell me what is the difference between those two? The first one has set 8. The second one has element 8. So here I was going to choose between subset or not subset, but in this case I'm going to choose between belong and doesn't belong. Does this element found inside of the set? Yes. So 8 belongs to set 2, 4, 9 and 8. Now we have set 8 and 3 and set 2, 4, 9 and 8. We want to know if all the elements inside the first set is found there inside of the second. 8 is found in both of them. What about 3? Does element 3 found inside of the other set? No, it's not found inside of the other set. So here, set 8 and 3, not subset to set 2, 4, 9 and 8. So we can say that set of counting numbers is a subset of set of natural numbers. Why? Because the set of counting numbers is set of 1, 2, 3, 4, 5 and so on, while the set of natural numbers is set 0, 1, 2, 3, 4 and so on. So all the elements which are in the counting numbers is found there inside. So the whole set of counting numbers is found inside of the natural numbers. But what about does natural numbers found inside of counting numbers? No, because natural numbers have an element called 0, which is not found in the counting numbers. So we are going to say that natural numbers not subset of counting numbers. But here we can say that natural numbers is a subset of z or integers. Why? Because natural numbers contain 0 and all positive whole numbers. And what about the integers? The integers or set z contains 0, all positive whole numbers and all negative whole numbers. So natural numbers are found all inside of set z. So that's why natural numbers is a subset of z. The last thing that I want you to remember, and it's very important, the phi. Do you remember the phi? Phi was an empty set. What is the meaning of an empty set? It was a set with no elements. And that's why phi is a subset of any set. Any set in the world, phi is subset of it. So let's have a summary of what we have said. We said that I have a counting number which contains 1, 2, 3, 4 and so on. This counting number is found inside of natural numbers. Natural numbers contain the number 0, 1, 2, 3, 4, and so on. And what about integers? Integers contain all negative whole numbers, 0, and all positive whole numbers. By now, we have finished the revision on sets. See you in the coming video. Thank you, Prep 1, and have a nice day.